This is notes 3.3, the empirical rule, and I'll be finishing off, this is part 3 of the notes, these last several practice questions dealing with the empirical rule. So question number 3 says the data set has a mean of 15, so we'll go ahead and label that x bar equals 15, and the standard deviation is just 2. And it says approximately what percentage of the observations lie between 13 and 17. So we can always go ahead and draw that horizontal line and put the x bar in the middle. And then we can calculate a standard deviation above and below the mean until we hit these two values. So if we do that, we add the 2 as the standard deviation and we subtract the 2 from the mean, we arrive. And we know that 1 standard deviation away from the mean is, we would assume 68% of the observations. And that goes back to our empirical rule on the first slide. So the answer to this question then is just 68%. Number 4, the data set has mean 30, so x bar equals 30 in this situation. Standard deviation is 4. Approximately what percentage of the observations lie between 22 and 38? So again, x bar always goes in the middle. And then 1 standard deviation away, if we subtract 4, the standard deviation, that's going to give us 26. Add 4, that's going to give us 34. So we have not yet arrived, so we'll do it again. X bar plus 2s and x bar minus 2s. So we just add another 4 on is 38. And subtract another 4 is 22. So now we have arrived. So now we are 2 standard deviations away from the mean, which we know is approximately 95% of the data. And that's the answer. What percentage? 95. The next question, slightly different. You'll see that they kind of go in twos and pairs in terms of the types of questions being asked. This time it says we have a data set of size 40. So remember n stands for the number of observations. How many observations lie within 2 standard deviations? So that's the 95% to either side of the mean. How many observations? So we go back to this data set, the size of the data set, and we just multiply 40 times 95%. Or 40 times 0.95. So go ahead and calculate that. Is 38. So 38 observations lie within 2 standard deviations of the mean. Number 6, the data set has size 80. So you can see this is the same type of question. Right now I would encourage you to pause the video and go ahead and try this on your own and then check your work. All right, so I'll go ahead and finish it. Approximately how many observations lie within 2 standard deviations to either side of the mean? Again, we're just taking 80 and multiplying that times 95% or 0.95. 80 times 0.95 is 76. So 76 observations lie within 2 standard deviations of the mean. Similarly, we have a size of 60. And now the question is asking how many observations lie within 3 standard deviations. So 3 standard deviations, that's 99.7%, which equals, if we want to write that as a decimal, 0.997. So now we're multiplying 60 times 0.997. 59.82, approximately 60. Since we're talking about a number of observations, we can have a decimal, so we'll round. Number 8 data set has 50, size 50. Approximately how many lie within 1 standard deviation, or 68%? So we'll multiply 50 times 0.68 on this one. I'll let you calculate that. The next one has 80 observations. And a mean, so this is changing it up, we have a mean on this one, is 30. Standard deviation is 5. Approximately how many observations lie between 20 and 40? So first we have to calculate how many standard deviations that is away from the mean. So if we add 5, we'd have to add 5 twice, right? So that would be 35. And then x bar plus 2s. So it's going to be 40. So we see that's 2 standard deviations from the mean, which is 95% of the data. So we'll multiply 80 times 0.95, which we actually just did in the question above. And we got 76 observations. We got a couple more here. The data set has 250 observations. Mean of 100, standard deviation is 16. How many lie between 52 and 148? Right in the middle, we'll put the mean is 100. X bar plus s, x bar minus s. So 116 and 84. And then 132. And then x bar plus 3s is going to get us to the 148. X bar minus 2s. So we subtract 16 from 84, and we get 68. Not there yet. If we subtract 16 one more time, we get 52. So that's 3 standard deviations from the mean. In other words, 99.7% of the data. Or we have to then put it back into the situation. We have to take the 250 observations and multiply that by 0.997 to get how many observations. That's the question. I'm going to go back and double check what the question is asking. So we do 250 times 0.997, and we get 249.25. Like I said, we round, so we'll get 249. Number 11, the data set has 200 observations, so n equals 200. Mean is 20. Standard deviation is 4. It just becomes second nature for me as I read this to write down the values, and that's something that you also want to get in the habit of throughout the course of this unit and even beyond. We'll be doing different problems that will require you to incorporate these values into different equations. And when you can identify the values and you know the formula, it makes it a lot easier to just plug those values in and calculate. Approximately how many lie between 16 and 24? So start, put in the middle, the x bar is 20. S is 4, so that's going to be 24, 28. Did we get there? Oh, we already got there. X bar minus S minus 14, or sorry, minus 4. So 20 minus 4 is 16. So that's going to be within one standard deviation, or 68% of the data. So we multiply 200 times 0.68, which is 136. Last one, the data has 150 observations. The mean is 35, and the standard deviation is 4. How many lie between 31 and 39? So if we subtract 4 from 35, we get 31. And if we add 4 to 35, we get 39. There's one standard deviation, and again, 68% of the data. So we're going to multiply 150 times 0.68. (102). So we would expect to find 102 observations within that range. So that concludes our notes for 3.3. Please, as always, if you have any questions as you move on and practice in the Math Excel assignment, let me know.